So today we are making an impossible part. Here's the catch. We got flatness of 2/10, we got parallelism of 5/10, and our material is 6061. Now I'm going to show you guys how I make impossible parts. We got this right here. We got a press fit for 750, and then there's some other fun detail right here. We want this 1.5 inch diameter boss. It's got an undercut. You can kind of see it right there. So there's a bunch of other fun details on this part. Now, last night I blanked it out, and we've got this. This is basically what it's going to look like. We got extra material over here, so we're good. Now look at this. I was just getting warmed up, and I was at 5/10. So what I got is I got my tense indicator on the surface plate. We'll get this all tuned up, and I got the probe ready to go. I'm gonna do inspection. I got 1-inch ring gauge, so we'll see how it's doing. It's all calibrated. What we're going to do for this guy, and I swear this probe is awesome. We gotta make sure everything's tuned up and ready to go. I warmed up the machine already, and so I'm approximate center. Now I have programs in here. Let's see here. Probe bore. And I keep these in the machine. And basically, this stuff up in parentheses, I ignore that because I've gone and edited. And, okay, so that's the corner. Sorry. Right there. That's where I put the diameter, and this is what we're going to save to. So I want to change that to 1 inch. So that's D 1.0 Ultra, and then I want to put that on 55. S55 point. When you don't put the point in there at the end, it doesn't work correctly. I've learned that, and I could be wrong. It happens. Now, on the current commands page, you got this. Here you got your M30 counter, and right here we can configure to display variables, and I'm displaying 189, and that's going to give me my diameter. So let's see if we can get something to happen here. So the probe's going. And there you go. So that's what kind of resolution we're reading on the 1-inch gauge. So I think that's pretty good. Now what I can do, I go back into current commands. Okay, so it's 188 is the bore. And I'm just going to put diameter. There. I just hit enter. So that's going to feed us our diameter. And 189, I guess I don't know what that is. But now, when I'm on my program page, see, it says diameter. So as I'm doing stuff and doing inspection, and I can add that in my program. I'll probably put a sub-program in there, and what that will do for me is I can do inspection on the part. Whoa, what the frick? Hit the wrong button there. Good grief. Haven't crashed the probe yet. Anyway, that's the type of tip I run there. Not the one that came with the machine. That's a CMM stylus. Haas will sell you something for like $200. you can get on eBay, get a thread adapter, and get a nice stylus for 10 bucks. And then you got something that will get into smaller holes. Haas sells a 6mm diameter tip. So those are my soft jaws, and I'll go over how to tune the vise. Let's get the gauge out. Put that over there. So the carrier jaw, I'm going to snug that up. I'm going to preload it. And what I'm going to do is I'm going to cut my step deep. I may get in there with a dovetail cutter and put a relief underneath. And basically, when I squeeze this part to face it off, what it's going to do is it's going to bow. So when I'm tightening it, I'm going to have my tense indicator on there, and I'm going to watch that needle move, and that's how I'm going to decide what the appropriate torque on the vise to put. Now, I want as much surface to surface contact I can get here. It's just like when we do surface grinding, we want to block it in. So I may put a stop on either side, because I'm barely going to be holding on to this thing, which is acceptable since I'm only going to be taking a couple thou off at a time. And the face mill I'm going to be using is a 3-inch face mill. I'm going to put sharp inserts in there, and I will check back in. I'm going to get this stuff all set up. I'm going to pause the video, and then I'll show you the setup. So one of the reasons I wanted to show you here why we call this the impossible part. This is my tense indicator. Okay, I'm on a 123 block. Now we use this 123 block as a gauge for setting tools. And look at this. So right there, even my precision equipment, my alleged precision equipment, isn't even 2/10 flat. So it is difficult. I would be willing to bet that I could measure ink from a Sharpie on that surface right there with this indicator. Anyway, we're just getting going here. We got the face mill reloaded, and then we've got the hydraulic chuck holding the 1/2-inch end mill. We'll get to that in just a minute. So I wanted to show you how the hydraulic tool is. We've got just one screw right there. This is a liner or a sleeve that closes up on a 1/2-inch end mill. And we've got a preset torque tool. And we just tighten this thing up and rock and roll. It's not too bad, and it holds it nice and straight. Alright, so I got the indicator on here. I'm going to try and show you this. And there we go. So that's loose, and I'm going to tighten it so it moves 1/10. Now, what I'm going to do is I'm going to lift on it just to get an idea as to how secure this thing is. And as you can see, I've got it buried pretty good. So I'm going to lift on it with my fingers. Okay? It's actually really stable. And I ran the indicator across this just to kind of see how out of shape it is. Check it with a micrometer, and it's pretty close. Right now we're 777 thousandths thick, and we need to get down to 750. So once we've got a nice way to hold it, I don't think I'm going to block it in just yet. Soon. So here we go. It's not going well. Part's not coming out flat. It almost looks like the carrier jaw lifting. So what I did was I rotated the part 180 degrees, and I'm rerunning it at the same V height. So hopefully that little bit of angularity will get cut off. But right now, it's actually a thou and a half, which is worse than before. So we're gonna have to watch it very closely. As you can see, when I rotated it 180 degrees, it cleaned up over here and not here. So I wipe it with Scotch-Brite, abrasive pad, just to, that way I get witness marks when the cutter goes back across it to see where it may have lifted, where it may not have lifted. I'm going to put a micrometer on here and I'm just going to see how it's coming out.